All right, so graphing cotangent functions. The graph of y equals cotangent of x. What is the period for cotangent? No, the period. You remember? We just talked about it. And just pi. Remember, tangent and cotangent have a period of pi. All right, so, and it tells us that in the next example here. It says the graph of the cotangent function will also complete one full cycle in the interval of from 0 to pi. So the period of y equals cotangent of theta is pi. And since vertical asymptotes will occur at 0 and at pi, will this interval show the complete function's behavior? So what do you think? If we have vertical asymptote at 0 and pi, do you think that's going to show the complete period? Well, what is the period of pi? What's the period of cotangent? Pi. And so if it goes from 0 to pi, is that a pi?
Yes.
Yeah, so it'll show it. And so that's what we're going to use as the vertical asymptotes for our cotangent function. So I'm going to pick some points, and I'm using the same exact way I did for tangent, okay? But I'm not just going to work it all out here. If you want to see how it works, I can show you individually. So for cotangent, we're going to use the x's of 0, pi over 4, pi over 2, 3 pi over 4, and pi.
Wait, why those?
Because 0 to pi will show us a full period, and this just breaks it down into even increments, okay? Because halfway between 0 and pi is pi over 2, and then halfway between 0 and pi over 2 is pi over 4, and between pi over 2 and pi is 3 pi over 4. So I'm just making some even increments there. Now, we could use those ordered pairs and take our, remember cotangent is x over y, and that would give us our y values, okay? But I'm going to tell you for 0, when I take x over y, we're going to get undefined. At pi over 4, when I take x over y, we're going to get 1. At pi over 2, we would get 0. At 3 pi over 4, we'll get negative 1. And at pi, we will find it's undefined again. And so it's going to look similar to tangent. It's just been shifted and it's been reflected.
Is that because it's just tangent flipped over?
Yeah, kind of, yeah. It has to do with that because we'll see that with secant and cosecant as well. They're just reflections of the sine and cosine graphs. All right, and so we could continue our pattern here. We know if we keep going to the right that our next point is going to be up at the 1, and then a 0, and then down at negative 1. And then we have an asymptote. If I continue my pattern going to the left, we're going to start down at negative 1, 0, positive 1, asymptote. We can keep going. So negative 1, 0, 1, asymptote. All right, something else while y'all are drawing that is be careful. If you try to use a calculator to graph these, the calculator is going to show you one of two things, okay? Either it's going to show you a bunch of little squiggles like this, which is basically what we've got because the asymptotes don't really exist. Or it might show you like a squiggle with a line and a squiggle with a line. And for some reason, it's drawing in those vertical asymptotes, okay? Before, I'd really just seen this on the older calculators, like the 83s. But I had a student who had one of the 84 plus color ones or whatever they are, the nice ones. And his was doing it as well. So I don't know if it's something he did in the setting or if it's something they've started doing again, okay? So They're not really connected, they're individual. And so if your calculator is showing they're connected, it's kind of showing you there's an asymptote there. I guess it's to help remind you. I'm not sure why they did that. All right, so looking at your graph, let's answer some of these questions below now.
Wouldn't the domain basically be the same?
The domain is almost the same, but my asymptotes aren't in the same place, are they?
No.
But it's the same idea of it, yes. So remember, for our domain, we're going to put where our angles cannot be, where our x's are not. So x cannot equal, what is one of my vertical asymptotes then?
Pi
Pi?
plus pi k, k-e-z.
All right, good. Plus the pi k.
Actually, like, for real?
Yes, because it happens every pi, and then because we use a k, we need to use our notation.
What does that even mean?
You remember that means that the k is an element of the integers. Integers, it's just a set of numbers, just like all the real numbers. Z is just a letter that represent them. Y'all have seen I know we talked about it briefly the other day. You've seen this to represent all real numbers, right? So Z is just what represents the integers, which remember are just positive and negative, what we think of as counting numbers.
So then wouldn't the asymptote be x equals pi plus pi k?
Okay, so my asymptotes are at x equals pi plus pi k, because they are where the domain cannot be. And anytime we use a k, we need to use that notation afterwards. All right, what about my range?
Negative infinity, positive infinity?
Yeah, it keeps going down and it keeps going up. So negative infinity to positive infinity. Where are my x-intercepts?
Pi is over 2.
So pi over 2. And we're going to have infinite number, right? Because it keeps repeating. So plus, how often does it take it to repeat? So pi k. And then what I'm going to do here, I'm going to write it as an ordered pair. So remember, if it's an x-intercept, it would be comma 0. And then I'm going to put my k as an element of an integer over here. All right, I didn't write the other one as an ordered pair, but we could have. And we probably should have. Where's my y-intercept?
None.
Okay, there's not one. Why not?
Because it's a little dotted line.
There's an asymptote there. Very good. Again, it's got odd symmetry, so that means it's symmetric to the origin. Do you remember which ones had even symmetry?
Cosine.
Cosine and?
Sine.
Nope, cosine's
Secant.
reciprocal.
Oh.
Secant. Good.
That's just common sense. The reciprocal. When you say cosine, they're twins.
And you said sine.
I said cosine.
Yeah, and then I said and you said sine.
Oh, that was just a random guess.
Okay. Okay, so let's do some graphing. It's the same idea, guys. Nothing's changing here. So an example for, I guess I can't say nothing's changing. The parent table changed, right? Because now we're dealing with cotangent. So example 4, it says we're going to graph y equals cotangent of 2x. So is that 2 going to affect my x or my y's? It's going to affect my x's. And what are we going to do to our x's?
Divided by 2.
Good, x divided by 2, which is the same as multiplying by 1/2. Good. All right, so what about the y's? Is anything going to affect them? Nope. Okay, y'all do the x's, I'll do the y's. Yes.
Christian, are we able to
Yes.
use them as divided by 2? Do we have to multiply by 1 half?
No, you could leave it as divided by
I see
2.
better when it's divided by 2.
Okay. Well, my only thing is when I have like pi over 4 and I divide it by 2, I just don't like that. So, but yeah, you can do divided by 2 and then simplify it out.
That's fine.
As long as we get the same answer at the end, you're good. Remember, multiply your fractions straight across. Once you get yours, check it with mine, and then go ahead and graph it.
I did it. I did them all backwards. Like instead of doing 1 over 2, I did 2 over 1.
Oh
Because I
no.
thought I put everything over 2.
All right.
I put pi, like pi over 4. I put that over 2.
Okay, so if you have the pi over 4 and you have it over 2, remember you got to get rid of the little fraction on top then that you don't like. So multiply it both by 4, and that would still give you the pi over 8.
Yeah, I didn't know how to do that, and so I started multiplying times 2 over 1. So I just did everything back.
Right. What's that? Okay. Let's.
I'm gonna be real close.
Has everybody got their table? Their table's good? I did okay on mine? I didn't make a mistake because it happens. Y'all know me. All right, so I went ahead and I graphed my asymptotes there. Now, the points in between aren't labeled, are they? But remember, let me change colors here. But remember that pi over 4 then is halfway between 0 and pi over 2. That's the middle point in the table, so it's got to be in the very middle. So that has to be that line right there because it's right in the middle. Now, pi over 8 here is going to be exactly halfway between 0 and pi over 4. So between 0 and pi over 4, so between that asymptote and my dot, the asymptote on the left and my dot, is going to be exactly halfway is pi over 8, and it's going to be up at 1.
Ms. Jumbo, we're allowed to use a calculator for this test, right?
We don't need a calculator for this test.
That's what we did.
All right, and then halfway, or 3 pi over 8 is going to have to be halfway between the pi over 4 and the pi over 2. So pi over 4 was my dot. Pi over 2 is that right asymptote. So halfway between it is 3 pi over 8, and it's going to be down at -1. And so there is my graph. And I want you to sketch another full period of it going to the left and to the right.
1.
Now be careful because when you do your pattern, remember we're only going over half a block, right? Not half a pi, I'm doing it by blocks. So from the asymptote to that first dot, I went right half a block and I went up 1.
1 could period be pi over 2.
Uh-huh. So I want you to do a full period going to the left and a full one going to the right. Now, if you want to do more than that, you are welcome to, but you don't have to. And then remember to find its period, you can use the formula. What's the formula for the period for cotangent? Yeah, still pi over b. So you could use your formula. You could say it's pi over, and in this case our b was 2. So it's just pi over 2. You could also just look at the graph there, and you can see, or the table even, it went from 0 to pi over 2, which is pi over 2. All right, we're ready to do B? All right. So we're looking at cotangent. Is there anything that's going to affect my x's?
Pi over 2.
That pi over 2. So what are we going to do to our x's?
We'll divide them by pi over 2.
We're going to divide by the pi over 2, which means the same as multiplying by what? 2 over pi. And is there anything to do to my y's?
What about the,
I got the plus 1, but what about the negative?
you
You
have
gotta
to,
multiply by negative.
Multiply your y's by negative 1 first, and then add 1. What was your question?
I was gonna say, do you have to distribute the negative?
Yeah, no, it's just a negative times that cotangent of the pi over 2x. All right, so remember, y does what's supposed to, so we have to follow PEMDAS, which says to multiply before we add. All right, so I have to think a little bit here. So for my y's, let's do them. My first y was undefined. What's undefined times negative 1? Plus 1. Still undefined. All right, my next y was a 1. What's 1 times negative 1? Minus 1.
Plus 1
Oh, yeah, plus 1. Thank you.
is 0.
0. My next y was a 0. What's 0 times negative 1?
0.
Plus 1.
1.
My next y was a negative 1 times negative 1, which is
1.
plus 1 is.
2.
And then the last one is undefined times negative 1, which is
Undefined.
plus 1.
Undefined. Those are always going to be there.
All right.
Basically, for these, we're always going to have the lines.
For tangent and cotangent. And
Okay.
secant and cosecant will have asymptotes too. It's coming. Just so you know. Okay, so let's see. For our x's, we said we're going to multiply by 2 over pi. So my first x was 0. So what's 0 times 2 over pi? Then we had pi over 4. So what's pi over 4 times 2 over pi? Yeah, the pi's cancel. We have 2 over 4, which reduces to 1/2. All right, then we had pi over 2 times 2 over pi. Everything cancels. So what do we get?
0.
No, not 0.
1.
1. So wait, I have 0, 1/2, 1. What's the next one?
1.5.
And the last one? What?
2.
2. 2 if you follow your pattern. Well, let's check.
I thought we were doing
Okay, we can do the other. So
I don't
it was pi, and we're multiplying by 2 over pi, right? So my pi's cancel, and I get 2. So we did okay. All right, so we can graph this. What's its period? No, the period, it looks like it's going from 0 to 2. I'm just looking at the graph there. So how far is that from 0 to 2?
2.
It's 2. All right. And do one full period going to the left and to the right. Do an extra one on each side.